In the last class, we have studied about partial correlation and multiple correlation. Let's study the partial regression and multiple regression in this class. So, partial regression of coefficient, you can also call it as least square normal equations. So, this is the equation in order to solve the partial regression coefficient. So, x1 is equal to a plus b1, x2 plus b2, x3. So, here you can see you can make it as a plus b12.3 x2 plus b13.2 x3. Instead of b1 and b2, I am going to consider b12.3 then b13.2. So, here x1 is estimated value of dependent variable. Okay. So, this is the dependent variable and a is there, right, small a, it is the regression constant representing the intercept on y axis. Then b12.3 and b13.2 is the partial regression coefficient values. So, here you will have to find out a, then b12.3 and b13.2 in order to construct this equation. Let us understand this concept by taking this example. So, problems on partial regression coefficient and correlation coefficient here. So, given the following, determine the regression equation of x1 on x2 and x3. So, here x1 on x2 and x3 and x2 on x1 and x3. Okay. So, here you have correlation coefficients between 1 and 2 is 0.8, 1 and 3 is 0.6 and 2 and 3 is 0.5. Then corresponding standard deviation values you have, sigma 1 is 10, sigma 2 is 8 and sigma 3 is 5. So, now you can write the equation here for x1 on x2 and x3. So, regression equation of x1 on x2 and x3. So, is given by, you can take that equation here, that is x1 is equal to b123 x2 plus b132 x3, where you will have to find out b12.3, that is sigma 1 by sigma 2 into correlation values, that is r12 minus r13 r23 divided by 1 minus r23 square. You just substitute the values from the given data in the question, that is 10 by 8 into 0.8 minus 0.6 into 0.5 divided by 1 minus 0.5 square. So, from this data you will have to get b12.3 is equal to 0.833. Similarly, you will have to find out b13.2 by using the equation here, that is b13.2 is equal to sigma 1 by sigma 3 into r3 r12 r23 by 1 minus r23 square. Just take the values here, substitute the values. So, 10 by 5 into 0.6, then r12 is 0.8 into r23 is 0.5 by 1 minus 0.5 square. So, you will have to get the value is equal to 0.533. So, now you can substitute the values into the main equation. Therefore, required regression equation is, you can take that equation x1 b12 dot 3 x2 plus b13 dot 2 x3. So, substitute the values here. So, x1 is equal to 0.833 x2 plus 0.533 x3. So, this is the required equation here. Okay. So, similarly, you can calculate the value of the regression coefficient based on x2 on x3 and x4. Apply the equation here. So, where B123 is equal to sigma 2 by sigma 1 formula. Okay. Then R12 minus R23 R13 divided by 1 minus R23 whole square. Substitute the values here. So, 8 by 10 into 0.8, 0.5 into 0.6 divided by 1 minus 0.6 square. So, you will have to get the value is equal to 0.625. So, this is the value for B12.3. Similarly, we will have to calculate B23.1, that is sigma 2 by sigma 3 into R23 minus R12 R13 by 1 minus R23 square. Substitute the values here. So, 8 by 5 into 0.5 minus 0.8 into 0.6 divided by 1 minus 0.5 square. So, B23.1 is given by 0.0426. So, this is the value. Hence, you can substitute the values into the main equation here. Therefore, x2 is equal to B12.3 x1 plus B23.1 x3. Therefore, x2 is equal to 0.625. So, here we have obtained B23.1 is equal to 0.046426. Therefore, the equation will be x2 is equal to B12.3 x1 plus B23.1 x3. You just substitute the values of B12.3 and B23.1. So, the equation will be x2 is equal to 0.625 x1 plus 0.0426 x3. Yes, you can consider the another question under the partial regression. In a triweight distribution, sigma 1 is equal to 3, sigma 2 is equal to 4, sigma 3 is equal to 5. R23 is equal to 0.4, R13 is equal to 0.6 and R12 is equal to 0.7. Determine the regression equation of x1 on x2 and x3 if the variables are measured from their means. So, here you will have to take this equation, that is the required regression equation of x1 on x2 and x3, okay, is given by x1 is equal to B12.3 x2 plus B13.2 x3, where B12 is 12.3 is equal to sigma 1 by sigma 2 into R12 minus R13 R23 divided by 1 minus R23 square. We just substitute the values in the from the given data. That is 3 by 4 into 0.7 minus of 0.6 into 0.4 by 1 minus 0.4 square. So, from this you will have to get 0.75 into 0.7 minus 0.24 by 1 minus 0.16. So, here you will get you just take 0.75 as it is in the numerator, 0.46 by in the denominator 0.84. So, 0.75 into 0.5476. Therefore, B12.3 is equal to 0.4107. So, this is the obtained value from this equation. Similarly, you can calculate B13.2. So, here you have a formula B13.2 is equal to sigma 1 by sigma 3 into R13 minus R12 R23 divided by 1 minus R23 square. Substitute the values here, that is 3 by 5 into 0.6 minus 0.7 into 0.4 divided by 1 minus 0.4 square. So, 0.6 into 0.6 minus 0.28 divided by 1 minus 0.16. So, you will have to get 0.6 as it is in the numerator, it is 0.32 by 0.84. So, 0.6 into 0.3809. Therefore, B13.2 is equal to 0.2285. Now, you can substitute the values of B12.3 and B13.2 here. So, hence the required equation is x1 is equal to B12.3 x2 plus B13.2 x3. The obtained equation is x1 is equal to 0.4107 x2 plus 0.2285 x3. So, this is the obtained equation from this problem. Let us take one more example under partial regression. An instructor of mathematics wishes to determine the relationship of grades in the final examination to grades on two quizzes given during the semester x1, x2 and x3 be the grades of a student in the first quiz, second quiz and final examination respectively. The instructor made the following computations for a total of 120 students. So, here instructor of the mathematics wishes to determine the relationship of grades in the final examination to the grades and two quizzes, say quiz 1 and quiz 2 or first quiz and second quiz during the semester of x1, x2, x3 here. So, the instructor made the following computation for the total of 120 students. So, here you have a mean from 3 semester, x1 bar is equal to 6.80, x2 bar is equal to 7 and x3 bar is equal to 74. Here S1 is 1, S2 is 0.8 and S3 is 9. And correlation coefficient between 1 and 2 is 0.6, between 1 and 3 is 0.7 and between 2 and 3 is 0.65. So, what is the question here? Find the least square regression equation of x3 on x1 and x2. So, you will have to find out the least square regression equation on of x3 on x1 and x2, and also you will have to estimate the final grades of two students who scored respectively 9 and 7 and 4 marks in the two quizzes. So, let us calculate the least square regression equation of x3 on x1 and x3, x1 and x2 here. So, here the regression equation of x3 on x2 and x1 can be written as, here you have a equation for that, x3 minus x3 bar is equal to r23 minus r13 r12 by 1 minus r12 square into s3 by s2 into x2 minus x2 bar plus, here you have plus symbol, plus r13 minus r23 r12 divided by 1 minus r12 square into s3 by s1 into x2 minus x1 bar. So, from this you can substitute the values. So, substituting the values. So, we have values in the question itself, you just substitute the values. So, x3 will you can keep it as it is, x3. X3 bar is 74, it is in the question, is equal to R23 is 0.65 minus R13 is 0.7, R12 is 0.6 divided by 1 minus R12 again is 0.6 square into, you will have to take S3 by S2. Here S3 is 9 and S2 is 0.8. Then X2 you can take as it is, x2 bar is 0.7 plus, you can take R13 0.7 minus R23 is 0.65 into R12 is 0.6 divided by 1 minus 0.6 square, that is R12 square, into S3 by S1. S3 is 9 and S1 is 1 into, you can take x2 minus x1, keep x2 as it is, sorry, x1, here you have x1, x1 as it is minus 6.8. Now, you can solve this entire equation here. So, x3 minus 74.00 or you just take 74 itself is equal to 0.65 minus 0.42 divided by 1 minus 0.6 square is 0.36 into 11.25, take x2 minus 0.7 as it is plus, you simplify this equation here, that is 0.7 minus 0.39 divided by 1 minus 0.6 square is 0.36 into 9 by 1 is 9 into x1 minus 6.8, you can take as it is. So, in the next step you can simplify this step by taking x3 minus 74 as it is equal to 0.23 by 0.64 into 11.25 into x2 minus 7 plus 0.31 by 0.64 9 into x1 minus 6.8. Now, you can simplify this step. you just write it as it is, x3 minus 74, just divide it, you will have to get 0.3593 into 11.25 into x2 minus 7 plus 0.31 by 0.64 is 0.4843 into 9 into x1 minus 6.8. Here you can take x3 minus 74 is equal to, if you multiply these two, you will have to get 4.04 into x2 minus 7 plus, you can multiply these two, you should get 4.36 into x1 minus 6.8. Now you can take this 74 into this side. So this minus 74 will become plus 74. So x3 is equal to 74 plus, you just multiply this 4.04 into this bracket. So you will get 4.04 x2 minus 4.04 into 7, that is 2.828. Similarly, you can multiply this value 4.36 inside the bracket. So 4.36 into x1 is 4.36 x1, take minus here, minus 4.36 into 6.8 is 29.648. So finally, you should get the value x3 is equal to 4.36 x1 plus 4.04 x2 plus 16.072. So this is the required equation of x3 on x1 and x2 here. So now you can consider the part B here. So what is the B here? The final grade of student who scored 9 and 7 marks is obtained by substituting take x1 is equal to 9 and x2 is equal to 7. It is in the question 9 and 7, okay, in the regression equation. So you can take the obtained equation and substitute x1 is equal to 9 and x2 is equal to 7. So 4.36 into 9 plus 4.04 into 7 plus 16.072. So you should get the value is 39.24 plus 28.28 plus 16.072. Therefore, x3 is 83.59 or you can round off this value 84. Okay. So, similarly, the final grade of 7 students. Similarly, the final grade 7 students who scored 4 and 8 marks can also be obtained by substituting So take these two now, 4 and 8 marks. So take x1 is equal to 4 and x2 is equal to 8. So, in the regression equation, you just substitute the values. In the regression equation. So, x3 is equal to 4.36 into 4 plus 4.04 into 8 plus 16.072. Therefore, x3 is equal to 65.832. So, this is the value of x3, that is 65.832.